Thank you for the to be here, and thank you also for Telegraph for inviting me in this venue. Today I will talk about a kind of journey in transpiling from Python to Python. But before, I want to just present myself. I'm Daniele Esposti. I'm a senior Python developer at Revolut. Previously, I was working in Badu as a team lead. My current job in Revolut is much more just a senior developer, but also I'm trying to build, I'm building from scratch an infrastructure to reporting for the company to different entities, banks and financial institutions in different countries. So, as I said before, we start to talk about transpilation and Python to Python journey. But first, I want to do a kind of small introduction about, before going to transpilation, I want to start with the basics, which is a compilation, which is actually translating source code into machine code. Everyone probably knows about the very famous piece of code hello world, and in this case I will show you a very simple example of hello world in C, which is pretty simple. Anyone knows about, if you don't know about C, that is very easy anyway. It's just a single function prints on the screen hello world, return 0, end of the story. No, not very complicated, not very fancy, but we're not here about talking C, we're not talking about language, talking about what's happening in this function when you compile it. Becomes this interesting, looks like random stuff, but actually this is assembly, x86-64 assembly to be precise, and that is actually what you saw before. Now becomes this kind of assembly code. And the next step is this nice representation, which obviously is not human readable anymore, like the previous assembly code, but it's still readable by your CPU, so it's much more useful for your CPU than yourself. So obviously, a little note, that output depends by different combination of compilers, which compiler you're using, which version of compiler you're using, which architecture you're targeting, all this kind of stuff. So don't blame me if I put the wrong assembly or the wrong binary output, because well, it was not that the point. Also, if you want to talk about this, well, it's a story for another day, not for today. So we realized actually compilation is transforming language source code into a machine language, machine code, internal language actually, because well, human use language is much more suitable for our brains, which should be much more similar to how we spoke and how we interpret things. But for computers actually, well, they don't care. They have a completely different approach about understanding a language. So the compilation step is just translating one language into another language. Or, well, you can do also the same with source code, right? Because the input is source code and the output is something else. That something else can be source code. We are not bound to translate always our machine code, because well, the translation process actually is flexible. It's just a matter of understanding what you have in input, transform it into something which is understandable from someone else in the output. So there's no point to just translate on binary or virtual machine or bytecode, whatever. You can also translate source code to source code. And that's become the term transpilation. Transpilation is actually source-to-source compilation. So you take source code and you output source code. The same language, for example, you take C, the output is C. You take JavaScript, the output is JavaScript. You can take JavaScript, the output is C, or Java into another language. So there's no even here, there's not any kind of a limitation on what you can do. But remember about this term, transpilation, so source code to source code compilation. Probably if in here there is someone which is a JavaScript developer or front-ender, you already know the name of at least one very famous transpiler, which is Babel. I think for sure you heard about in some way. That was actually a very interesting project which came out some years ago, and which allow actually you to have you write the JavaScript code in the latest version of the JavaScript, ES6, ES7, ES next, whatever, and then you run in your browser. And the browser supports just ES5. How is possible? You transpile. You take the source code, you convert it to source code in something else which works on a different platform. So that, for example, is a small example of the transpilation done by Babel. The first line is ES7 code, which most of the browser doesn't work. Well, Chrome probably yes, but older browser they don't work. And it's translated actually it's still JavaScript, right? But now it's compatible with ES5, so you can run in any browser. So we have a very nice example where actually the code is still doing the same. It's idempotent, but the way it's written is completely different because the translation process it just converts this code on the fly automatically without human intervention. But how does it? What are the actual steps of the transpilation process? Because it's kind of similar to the compiler, but not really, because it's kind of more simple because you don't need to go through all the phase of compilation to machine code and linking all the stuff. So you still have source code on the output, so it's much easier. This is a small schema. Probably is too small, but hopefully it's still readable. So you take the source code, you parse it, and then you have an abstract syntax tree. The abstract syntax tree for AST for friends is just a tree where every node is one of the block of your source code, and then you just apply transformation on this tree. And at the end, you just generate code out of this tree, because this tree is just a representation, a machine representation of your code. So you can go from your code, AST, and back. So the first step is actually tokenization, taking your source code, extract all the keywords, all the variables, all the words actually in your code, and decompose them in small tokens. And then it just parses this token in a way using the grammar of the language. So that produces, first of all, checks actually your code is valid, because you can still tokenize it by is invalid. Then the parsing actually does the actual validation and construct an ST. And then now you have this beautiful tree which represents your code, and you can apply transformation. You can, for example, transform your code to rename all the variables, prefixing, removing some other information, or just move, for example, methods or inline other methods. You can do any kind of transformation you want actually. Then you have the this AST transformed, and you can just output converting back in the original source code or new source code for a different language. So it's a very simple step. It's much more simple actually by the compilation step. We talk about JavaScript in general compilation, but because my talk is much more related to Python, there is this nice package called Astor, which is allow you to take a source code, convert it into AST in Python, and back from AST into Python code. Actually, this is a key point because out of the box, Python can obviously parse Python code into AST, but if you don't have the way to convert back the AST into source code, that will be kind of difficult to create a transpiler actually. And to write this kind of package is doable, but actually some people or some guy actually did that for us, and it works very well. Use it for Python 2.7, 3.6, and 3.7. There are some issues in 3.8, but it's working fine for the standard versions and the stable versions. So this is actually what I use for my small proof of concept of a transpiler in Python. The basics to using Astor are very simple. You just take your string which contains your source code and you call the AST parse, which generates the tree. This is actually a representation of the print hello world as a AST in memory, and then the next step is just generate the code out of the same tree. So this actually is an OOP because I just taken the same source code, converting AST, and then converting back in the original source code without any kind of transformation. But I can see it's very easy to parse code and generate code. It's just a couple of lines of code actually using Astor. And then actually is the code, source code regenerated. So the next step is we know how to take some code, converting some Python code, converting in AST, and then how to convert this AST back in source code, which is fantastic. But now we need to transform, or at least know how to do the transformation. And Astor give you a nice interface for that. It's very easy. You just have a class treewalk. You just subclass this class. And the class automatically have a way to walk through the AST, and you can implement any method to do some kind of action when you encounter one of the nodes or type of nodes into the AST. The method are called init and post. If you did computer science, you remember init is when you traverse a tree and you encounter a node, you can do some operation before continuing the node. And when you encounter the node, before doing actually going into the children, and after you go into the children of the node. And that works in the same. So init when you actually encounter the first time the node, praise before going into all the children of the node, and post after. And you just instantiate the class, your subclass with the AST you just generate out of the original source code. So now, just to give you some kind of more concrete example, I will show you how to write with Astor a transformer to remove all the notation from your Python code. I will do some introduction. Between Python 2.7 and 3, one of the one of the big changes they introduce are also the annotation. Annotation are just kind of types for the variables and for the function, whatever. They are not enforcing the doesn't make Python a static typing language. It's just a notation for developers, for documentation, and you can use also for static analysis using MyPy or stuff like that to understand if the code is correct. But in general, doesn't force Python the type. If you want to use obviously this code in Python 3, it's fine. Python 3 support annotation. But if you want to use this code in Python 2.7, you cannot use it because in 2.7 we don't have annotation, so the code will not work. So you want to have it to remove this kind of annotation. But before, I want to show how it works, for example, assignment, because I see before here, annotation, I just show you the annotation for assignments. I don't go for functions or class or whatever else, because it's much a little more complicated, but we show just how to remove the annotation out of assignments. So now I will show you what's the shape of an assignment, because we need to know how is the shape of the S3 tree before be able to modify the tree in the way we want. So the first line is the actually line of code, and the second line block is actually your tree out of the line of code. The entire assignment is just actually a single node, and you see that actually there are three children. One is the name of the variable, the name of the type, and the actual value. Breaking down a little more, an assignment is the node actually which includes all the assignment operation. Answer, the name of the variable, is the target attribute of the node, and you use another node called name, which has an ID, which is actually the literal of the which contains the name of the variable, and so on. Int, which is the type, is going into the annotation attribute, is still a name, and is just literal int. Interestingly, the equal operator doesn't have any kind of node, because obviously, well, the assignment is an assignment operation, so the equal operator is the equal token is still is part of the actual node, the meaning of the node. So there's no point to have another node in TST which represents the equal, because it is already implicit. And the last is the value you want to assign. Again, value attribute. In this case, it's a number, so you have a different kind of node. Instead of name is a number, is a literal as well, and the value of the literal is 42. And this one is the code you want. So in the first line, actually, the only difference is we just remove the annotation, so the colon int is gone. On the ST side, it's kind of different now, because the node is not anymore the unassigned node. It just assign, and we are missing actually the annotation attribute as well. Again, assign. Answer is going to target. 42 is going to value, which is a literal number. And this actually is the implementation of a transformator. So this code transforms from annotation without from an assignment with annotation to an assignment without annotation. Is really probably 4 or 5 lines of code. If you exclude also the import as well, which is kind of mandatory. So what you need is just you import the tree bulk, you create your class out in a subclass out of the tree bulk. I call it this class strip annotation transformer, just to because well you can have a multiple transformation, right? This one maybe just remove annotation from the assignment, and the other one probably just remove annotation from a function, whatever. So you can also chain them. You have the pre and assign. As I said before, pre is when you encounter first time the node. So actually, pre is when you encounter the node, and then after the underscore is the name of the node you want to detect. And then well, the only thing I need to do is I create a new node. So from the ST, from the standard library of Python, I create a new node assign. I collect the information needed. So in this case, I want from the current node target and current node value. I don't need anymore the annotation because it's not supported by the canon node. And I call an API on a store, say, okay, now this is a new node. Replace the current node with this one. End of the story. Very, very simple. Obviously, this is kind of, not say pointless, but is just an example. You can do much more complex transformation out of that. And for this, I created this kind of a small project, which is still in a very, very alpha phase, called PyTranspy. Is a kind of framework to allow you to write any kind of transformation in Python. So you just create a new transformation, write it, and then on the command line, you just call the PyTranspy with the input file name and the output file name, and you generate, take the code, pass it, apply the transformation, output the code in your directory. And if you want, it's a completely open source on GitHub. You can have a look, you can comment, you can contribute, you can do whatever you want. But what you can do with Transpiler, because yeah, it's fine, it's nice, but what you can do, well, good amount of things you can do actually in Transpiler, even in Python, which usually doesn't suffer the problem of JavaScript. You can have, for example, convert your Python code into a previous version of Python, because maybe for some reason you don't want to target the old version manually, or stay on the old version. You want to go to a new version and be compatible with the previous one as well automatically. You can write your converter, so your transformation to target, for example, 3.6, and you write in 3.7 or 3.8. You can also, all the way around, migrate your code to the next version in language. So, for example, let's say in 3.7 they have the data classes and you want to use them and you want to convert your code automatically. Maybe you just create a transformer which detects a class with some attributes and convert the class into a data class. You can do it. It's easy. You can also automate code updates on medium and large code base. An example is, you're using a very nice library. This library has a new major version. The new version has an incompatible API, so you need to actually go back on your code and change most of the part of your code, but the change is not very easily doable by just find and replace, because maybe variable names or difficulty is not just a find and replace operation. Maybe just changing also the shape of some classes or the way you call some API on the library. And then, you can use a transpiler, because you can dictate the operation, you can dictate while you're using this library, and you can transform the code to work for the next version. An example, I did the same thing when we upgrade in Badu. We upgrade from D3 version 3 to D3 version 4. It was completely different, and I wrote a certain transformation in JavaScript to convert our code base automatically for the next version. You can do also in Python in this way, using PyTranspy. You can also do some kind of custom code refactoring, like I don't know, some part of the code, some patterns you have in your code base you don't like anymore, or there is a better way. You don't want to go through all the code base manually and find this pattern and modify it. You can just, invite a transformation, which detects the pattern of your code and convert the pattern into a new pattern, for example. You also could generate, because maybe from some part of your code you want to extend that part of the code with extra code around. You can generate extra code, or you can remove code. For example, you put a lot of code, a lot of tests, a lot of runtime checks, and you don't want the if dev then checks this, you want to remove it because it's a performance issue, performance penalty. So in this case, you can write your transformer to detect all the debug level code and remove it automatically, so it will not go in production with debug code. So there are, anything else? Anything else you can think of about changing your code programmatically? It can be done, because it's just a matter of taking a tree and converting it into a different tree. And because with Astor you can also analyze and inspect the tree at runtime, you can actually do whatever you want with your code. So yeah, that was the my small contribution for tonight.